Hi, this is the third and last section in chapter 6 that we're going to cover. And this is going to cover some of the operations, that means add, subtract, and multiply, on matrices. So far we have done the Gaussian elimination to use matrices to solve, but matrices are actually used for a lot of things. And we're going to talk a little bit about matrices in general this time. So a matrix is any rectangular array of numbers. It can be any size. The numbers in the matrix are called the entries of the matrix. And we denote that it's a matrix by enclosing it in a square bracket that covers the whole thing, like we did in the last section. And we usually name them with capital letters. Okay, so an A, this is matrix A, right here. And this is matrix B, right here. And we actually also name the entries according to where they are. And everything in matrices is rows first and then columns, rows and columns, okay? So just get that in your head. Rows are first. It's always rows and then columns. So if I wanted to name this entry right here, so if it's a capital A is the name of the matrix, then I would use a lowercase a with a little subscript saying that it's on the first row and the second column. And that would be -3. So if I wanted to name A second row, third column, that would be a -1. So I can actually name any of them. And in this one over here, I would use B 3, 2. So that would be the item in matrix B, third row. So third row, the bottom row, second column, and that would be equal to 0. Okay, so in that way we can pinpoint any entry in the matrix. And we also define them as we call it the order, right, according to how many rows and how many columns. So matrix A has 2 rows. So the number of rows, number of rows would be 2. Number of columns is 3. So this matrix A is a 2 by 3 matrix. Matrix B has 3 rows and 3 columns. So it is a 3 by 3 matrix. That last one we just did, matrix B, because it has the same number of rows as columns, we call that a square matrix. We often refer to the diagonal entries, and that would be these right here, right down the diagonal, starting in the upper left-hand corner. So you can imagine it only really gives you a diagonal if you have a square matrix, right? Now, when we did Gaussian elimination, we sometimes talked about the diagonal, but it was of the main part, not the augmented answer column, right? So that main part was square, and then we tacked on the other column. Okay, so this is sort of a general look at any size matrix. Matrix can be any size up to, we're going to say m rows, and n columns. But you see that every single item in there has a way to be named. Somehow I'm not back to normal. All right, so And that size is by column. So here's the first thing I want you to look at. We already did a couple of these. I don't know why some of these have got round brackets, because we do square brackets with matrices, but go ahead and pretend like they're square and give me the order of each one of those. So if you want to, your paper has them all written with square brackets. That's how they're supposed to be. If you want to pause the video for a second and do that, that's probably a good idea. And when you come back, I'll let you know if you were right. All right, so hope you were able to do it. This one over here is a 2 by 2, right? 2 rows, 2 columns. This one up here is a 2 by 3, 2 rows and 3 columns. This little one over here is a 2 by 1. And the one in the middle here is a 3 by 2. And this one over here is a 2 by 3. Even though you have fractions, it's one entry, right? And this one right here is a 3 by 3. All right, so matrices are equal that if and only if all of their corresponding entries are equal. So that means if they're going to have corresponding entries, they have to be the same size. So we cannot talk about matrices being equal if they're not the same size. It's not. It's not even true, right? It can't happen. All right, so here are a couple of matrices. A is a 2 by 3 and B is a 2 by 3, so they're equal in size. So I want you to see if you can look at each of these terms and figure out what A, B, and C are. So pause the video and see if you can figure that out, and then come back. All right, I'll bet you figured it out, because there's several places, but the easiest one here would be that 1 is equal to 1 plus B. So right off the bat, we know that B is 0. And 2 is equal to C. So we know C, oh, looks like an E, but that's a C, is 2. It's taking me a bit to get used to using a stylus, but A is then equal to -10. Okay, so this one might be a little bit trickier, but pause the video and see if you can figure out A and C. Okay, there were several places to find both A and C, but this was a nice simple one. A is 4. And this was a nice simple one for C. C is 3. And if you look around at the other places, that fits in exactly right. This is going to be 12. This is going to be -2/3. This is going to be 5/8. So everything else works. So we can add or subtract matrices. But again, they have to be the same size. Okay? They have to be the same size, or because we do it term by term or entry by entry, and so if you had a different size, you wouldn't have ones that match, right? So, and the answer is going to be the same size again, because we get one for each entry and the other ones, right? So we go entry by entry, right? So if they're not the same size, then there is no answer. You can't do it, right? All right, so let's just do this first one together. A plus C, are they the same size? Yes, they are the same size. So we add them term by term, going in the place, right? First row, first column, first row, first column. So that's going to be 2 plus 3 is 5. 6 minus 2 is 4. 1 plus 1 is 2. 0 plus 5 is 5. 1 minus 4 is negative 3. And negative 3 and 3 is 0. All right, so what about A and B? Hopefully you noticed that those were not the same size. So that has no solution. So pause the video for a second and do the subtraction of C minus A. And see if you can figure out what it would mean to subtract. It needs to be consistent with everything else we do, right? Okay, when we subtract, just like everything else, we're going to add the opposite. And when we're looking at the opposite of a matrix would be, just to change every sign, right? So this would be negative 2, negative 6, negative 1, 0 stays, negative 1, negative 3. And now we're just going to add them, right? Since subtracting is just to add the opposite. All right, so now we add them. 3, negative 2 is 1, negative 2, negative 6, negative 8, 1, negative 1 is 0, 5 and 0 is 5, negative 4, negative 1 is negative 5, 3, negative 3 is 0. Okay, so the first kind of multiplying that we do is called scalar multiplication. So this isn't really multiplying two matrices together. This is multiplying a matrix by a constant. So if this is my A, then 3A, and you notice that I can write it like it's a multiplication problem. 3 times A, but A is a matrix, right? So just like you might think, we're going to take 3 and multiply it by everything inside there. So 3 times 1 is 3. 3 times negative 2/3 would be negative 2. 3 times 6 is 18. 3 times 4 is 12. 3 times 12 is 36. And 3 times 5/8 would be 15/8. And as we've mentioned before, you really don't want to change. Just leave it as fractions. Now an 8 would be a terminating decimal, so it would be okay. But typically, we just leave in fractions. We don't need to do anything with it. Okay, pause your video and see if you can get these two. We're doing 1/2 times B and negative 4 times A. Okay, so 1/2 times B, I'm going to have 3 halves. Negative 2 times 1/2 would be negative 1. 0. 6 times 1/2 is 3. Negative 4 times 1/2 is negative 2. And 0.4 times 1/2 would be 0.2. Now do negative 4 times A. That's going to be negative 16, negative 12. Negative 4 times 1/2 would be negative 2. Negative 4 times 1 would be negative 4. Negative 4 times 0 And negative 4 times negative 3 would be positive 12. All right, so that's the scalar multiplication. And we can actually combine all these things we did with something that looks like an algebraic thing, right? So 5d plus 3h. So the 5 and the 3, they don't change the size, so we can just double check. This is a 2 by 3, and this is a 2 by 3. So yes, we will be able to add them together. And we're just going to do 5 times g plus 3 times h. So pause the video for a second and see if you can get that before I show you how. Okay, so I'm going to just do these matrices multiplied out, right? So I got 25, negative 30, 25, negative 35, 30, and 5. And add that to 3 times this one, so it'll be 21, negative 12, 3, 6, negative 15, 21. And then I add them together. So 25 and 21 will be 46. Negative 30 and negative 12 will be negative 42. And 25 and 3 will be 28. Negative 35 and 6 will be negative 29. 30 and negative 15 will be positive 15. 5 and 21 will be 26. So let's see, we can combine the adding and the scalar multiplication. Okay, so here's the matrix multiplication, and this gets a little bit complicated, so bear with me as you get it, but as we start explaining this, but you'll be able to get it as we do some problems, okay? So it involves multiplying the row. So we're going to take a row of the first matrix with the corresponding column of the second matrix, and then we're going to add them together. Okay, so we can only multiply two matrices together if, when you set it up to multiply, the middle two, so that is the column on the first one matches the row on the second one. Okay, otherwise, when we take the row and we take the column, they're not going to match up. The answer is going to be the outer numbers. Okay, so I know this looks kind of complicated. But for I think what this is trying to tell us is that for the answer, any term, any entry is going to come from the corresponding row and column. Okay, so if I have in my answer the second row, third column, that is coming from the second row of the first matrix and the first column of the, did I say second row, first column? Yeah, so that would be the first column of the second matrix. Okay, so I'm going to show you a little animated thing. There's no sound with it, but I want you to watch as it kind of animates the rows in the first column. Kind of moving and matching up with the columns in the second one, and watch the addition and subtraction. Okay, so you see the first row, it matches up, and that matches with the second column, the third column, or sorry, the second row, first column, second row, second column. You notice that when it matched that up, let's see if it'll do it again. Okay, let's, oh, it won't pause. Okay, so let's pause it for a second. You notice that we had the 1 and the 2. Oh, I started again. From the first one, always the rows. Remember how I said everything is rows first and then columns? So it's always the rows in the first one. It's the columns in the second one. All right, so this will make more sense when we start doing some. We're going to do these little problems here, okay? So you should write this down and follow along, and I'm going to have you do some of them yourself. All right, so we're going to start with A times B. I'm just, let's leave that. So, since they're written in the right order, I'm not going to recopy them, since I really don't write very well on this, with this stylus, but I'm just looking at this row, remember it's the first one, and this column. So that row tells us, because we're using the first row, our answer will be in the first row. And we're using the first column, so our answer will be in the first column. So what I'm doing is I'm getting this little answer right there. Okay, now I'm going to take that first row, -2 and 1, match it up with the first column, 4 and 6. We're going to multiply those. And then we're going to add them. And so that is a -2. Okay. All right, so now I'm going to find the first row, second column. Okay, so I'm going to use the first row and the second column. So first row and second column multiply, and then you'll add, and that one's going to be -5. Okay, so I know this is going to, my answer will be a 2 by 2, because remember that this was 2 by 2 and this was 2 by 2. These match, so we can multiply them. And the outside ones tell us how big, so I will have a 2 by 2. So this time I'm looking for the second row, first column. So I'm going to use the second row, first column. So the second row is going to be 3, 4. The first column is going to be 4, 6. That's going to be 12. And 4, 6 is going to be 24. So it's going to be 36. And then finally, we're going to do the second row, second column. So I'm going to use the second row, second column. So that's going to be 13. Okay, now 3 by 3 is going to be the very same.
Mom, what are you making?
It's going to be it's just going to be a bigger one in the end. All right, so first of all, we know we can do it because this is a 3 by 3, and This is a 3 by 3. These match, so we can multiply, and our answer will be 3 by 3. All right, so put it over here. I'm going to do the first one, and then I want you to see if you can do the rest of them. Okay, I'll take the first row, first column. We multiply them. We add. So the first one is a 0. So pause the video and see if you can do it. I'm going to keep working. When you come back, you can see if you have the same answer or if you need to watch part of it from something that I did. So first row, second column. It's going to be -2. And -8 and 1 will be -7. Let me get a different color for these. We're getting a lot of colors here. This one is nice because these are just zeros, so it's a 2. We do the second row, second column. So that's going to be 11. And second row, third column. That's going to be -3. Sorry. I'm going to change color again so I can keep track of what I'm doing. So now I've got 4, 1, -1, and 2, 4, 0. It's going to be 8. 4, the other one will be 0, so that's a 12. Oh, I'm sorry about this handwriting. I have 20, -1, and -3, so it's going to be 16. And last one. 7. All right, so be careful as you do this. If you find that you're making little mistakes, you write stuff down more. I think that you'll get to where you don't have to write all these problems down. You can just kind of do it in your head. All right, I want you to turn the video off and do this one. And turn it back on. I'll give you the answer. All right, so hopefully you made sure to rearrange these. It matters. This matrix multiplication is not commutative. Okay, so if it's written the other way, you should write it down. Don't just use the printed one because you're used to doing it. First one's a rows, the second one is columns. Okay, so we have the row and the column. So 2 and negative 2 is negative 4. 5 and 1 is 5. 1 and 4 is 4, so that's going to be 5. And now we're going to do this one. 2, 5 and 0, and 1 and 1, so that is going to be 3. And we have 6 and 10 and negative 1, so 16, that's going to be 15. And now we'll do the second row, first column, that's going to be negative 8, negative 1, and 4, so that's negative 9 plus 4, that's going to be negative 5, and 4, and 0, and 1, that's going to be 5, and 12, and negative 2, and negative 1 is going to be 9. Now we'll do the last one. First one's 0, that's nice, 0. And then 3 and negative 8, so that's going to be negative 5. And 0 and 0 and negative 2. And 0 and 6 and 2. That's 8. Alright, and that will be DC. Alright, so these two, if I want to multiply A times E, can I? You should think about that first, right? These are not the same size, they're not square, but this is a 2 by 2, and this is a 3 by 2. So they do not match. We cannot do that problem. Not possible. I suppose instead of crossing it off, I'd write empty set or no solution or something. Now, when I do E and A, then I've got them switched, right? E is first, and that's 3 by 2. And this one is a 2 by 2. So yes, they do match in the middle. So yes, I can do E times A. So I want you to pause the video and go see if you can do it. And then while I will work this out and come back and see if we got the same answer. So go ahead. Okay, so remember we're doing negative 2, negative 1, and negative 2, 3. So I got positive 4, negative 3. It's going to be 1. I got negative 2, negative 1, 1 and 4. So I got negative 2, negative 4. So that's going to be negative 6. I got 3 and 0. Negative 2 and 3, so that's going to be negative 6. And 3 and 0, so 3 times 1. Then I've got 1 times negative 2, 2 times 3, so that's going to be 4. And 1 times 1 and 2 times 8, 4 is 8. So it's going to be 9. Alright, so that is the EA. Okay, 2 more. C squared. What do you think it means to have C squared? Well, think of it as C times C. So write out the C and the C and do that problem. And what do you think it would mean to have three of them together? Then we would just kind of do them in order. We would do EA, and then when we get that answer, we would do that times B. All right, so pause the video and see what you can get for these two. I have worked them out already. When you come back, I'm just going to give you the answer. I'm not going to make you go through every step. I think you probably have it by now. If you did not get the same answer and you can't figure out why, then when we meet in class for this section, we can work through it. We can work through the whole thing if you want. All right, so pause the video and go do that. Okay, you're back. These are the answers that I got. Now, I am just working these out like you. Totally possible for me to make a mistake as well as anybody. You know that. That is what I got for C squared. And for EAB, I got a 3 by 2 matrix. Let me know if you think I did those wrong, or if I made some mistake in there. Right. Okay, that's all there is for this section. Mainly, you just really need to practice the multiplying matrices. The other part's pretty straightforward, but I will see you in class and be glad to work out some more problems or help you with anything you had questions about still from the video. Bye.